Hello everyone. I was told that this talk is going to be given in English, also because, as far as I know, we have some people in the audience who rather don't speak Polish, so that's why it's going to be in English. However, if you have any questions, I think you can shout them out in Polish as well. Tonight I'll be using microphone because I'm a bit sick and I had kind of a difficult night, let me put it that way. So I'll use this help of the microphone. Let me grab the presenter. Okay. So today's talk is what's new and noteworthy in Java 12 and Java 13. So if you don't know me, my name is Piotr Przybył. These are the addresses here. And here where you can send me your questions, your feedback, your hate, whatever. I'm self-employed as remote freelance software gardener, also work as a trainer for a few companies, one of them being Shenandoah. If you don't know me, I'm mostly the Java guy, or better say the JVM guy. I'm so much haunted by Java that it's even following me when I'm on holiday. So even in Spain, I see Java behind my back. Question is, who are you? Are you Java developers? Yay! Great. Who's not Java developer? Okay, yeah, get out. I'm joking. Okay, who's running Java 8 or before, or early version? Okay, who has at least experimented with Java 11? Okay, anyone working with Java 12 or 13? A few brave souls. Nice. Do we have developer? Yeah, you're not Java developer, so we know that. Okay. Agenda for tonight. So first I'm going to describe the concept of preview features because finally since Java 12 we can observe the concept of preview features in real. And also the stuff that Java 12 and Java 13 brought us. So short reminder first, before we dive into preview features. The new release schema, if you don't know that, now every new major of Java is released every 6 months. And it's not postponed by features. I mean, if feature doesn't make it, it's postponed or even unmerged like row strings were. And Oracle, for its JDK, releases long-term support version every 3 years. That's why Java 11 is long-term support from Oracle's point of view. And I mean, of course, Oracle's JDK. All the other versions are kind of, let's say, regular versions. And this also means that there's instant lack of support for OpenJDK. I mean, once Oracle releases Java version X, the previous one is not supported anymore by Oracle. You can see that in this beautiful image I borrowed from Simon Ritter. So we are more or less here. Just Java 13 was released a month ago, and these gray boxes you can observe here are more or less they are OpenJDK now. For Oracle's machines, we have OpenJDK, or we have the paint versions like this pinkish one or the red one. So if you like to have to stick with Java 11, and if you want Oracle to be your vendor, then you need to pay here, or you need to upgrade. That's why they call it the support cliff, meaning also that, this triangle of things to choose. If you want to be secure, I mean, if you want your JDK to be patched with security patches and other stuff, there are two options. You can either be free, but then you're not stable, meaning you have to upgrade every 6 months, or if you want to be stable, then you're not free because you have to pay. But that's everything. As you can see, it's for Oracle, and for Oracle. But we need to remember that there are also other vendors and JVM/JDKs. I mean, Java doesn't mean that you have to download it from Sun/Oracle's webpage. You can also have other vendors as well. You can repeat after me that Java 11 is not paid, because this is this conversation I keep on hearing or keep on reading, about these folks wearing tinfoil hats, which prevent them from cosmic radiation or 5G. They believe that the Earth is flat, and they also keep saying that Java 11 is paid, which is rubbish. Java is still free. You can read that under this beautiful link. One of the things is you can follow is this adopt OpenJDK. You can go to their page, because once Oracle kind of abandons OpenJDK, there's a kind of consortium or a group or whatever we call them, and they kind of take care of OpenJDK once it's abandoned by Oracle. So you can choose various versions, of course not OpenJDK 8, I believe, but let's say 11 or 13. You can choose the engine, and then you can select the platform like Docker, various operating systems, or even Windows if you prefer, if you have to. So there's also this question people keep saying or asking, shall I migrate to Java 13? Or stick to latest LTS, because this 12 or 13 or 14 in the future is only supported by 6 months. Well, the answer is it depends, obviously. It depends on many factors. Because if you need to either challenge this support cliff, or find yourself a de facto long-term support vendor. As far as I know, for example, Azul said that they're going to support old versions. They will support 13 and 15 just as if they were LTSs. In fact, they still support Java 6, as far as I can tell. So they're quite good at supporting stuff. You could also see that OpenJDK still supports those versions. So you can find a vendor who supports them longer than 6 months. That's one thing about runtime and compiling, but if you want to run it in a cloud providers may not have it. So if your runtime platform is the cloud, whatever it is, then they might have just 8, 11, and that's it, like Amazon, I believe. If you decided to go for version 12 or 13 because of the preview features like switch expressions or text blocks, then you need to remember that it's really, I'd say, problematic to release your artifacts having class files using these features, because then the people, if you have, for instance, an on-premise or a standalone program, they also need to enable in their JDK these preview features. So it's not only that you need to tell the compiler that you enable these features, but also they need to enable them for the runtime. Even if a preview feature doesn't change, or if it changes slightly, you need to recompile your code for next major release, basically. So if you compile your code with preview features for JVM 12 or JDK 12 to run it on JVM 13, you need to recompile the sources to get new class files, basically. Provided you're using these preview features. And still we need to remember that there are some advantages, like you can benefit instantly from better performance, from better garbage collectors and stuffs, and these might be worthy, like the migration we had for Java 9, for example. Companies which migrated directly to Java 9 without waiting for 11 were able to save quite significant amounts of money because of compact strings, for example. And in Java 10, which wasn't LTS as well, we had much better Docker integration, which was finally working, actually. So that's why sometimes it makes sense, from performance and money reasons, to jump to non-LTS versions. Also, if you decide to use preview features even for small production systems, you can still provide your feedback for the Java team, because that's the whole purpose of these preview features. So we use them in small applications. We test them. We can even use them in production if we control the production, and then we can provide feedback so they can change something. Like they change, for example, switch expressions. So we don't have breaks but yields these days. And last but not least, it's about this joke in Polish. Jak najlepiej zjeść słonia po kawałku. So eating an elephant at once is really problematic, but if you eat it piece by piece, it might be easier. So jumping, provided you're running 11 now, directly to 17 after 2 years, 2 years from now, and after 3 years, might be quite challenging. So it might be easier to stick to Java and to perform these small upgrades every half a year, basically. So as you can see, there are pros and cons of using non-LTS versions. So it's like you need to choose based on your context and your constraints, what you can afford, what you can't. But we need to remember that people kind of think that these non-LTS releases or preview features are banana soft. They're not banana soft. They are released with exactly, as far as I can tell, with exactly the same care. And even preview features aren't just like, incubating or under development or something. They are ready at the same stage as the previous features were. It's just they still want to have instead of jumping right into our production, to have an option to change something, to update something. That's why they're called, some features are called preview features and need to be enabled explicitly for compilation, for runtime, but they are not so-called banana soft. They are quite solid, I'd say. So Java 12 was released in March this year. It has these JEPs, if you want to read them. And Java, there were of course 2 minor releases. One released a month after. It has new era for Japan, because from May the 1st this year, there's new era in Japan, as far as I can know. Because the previous, how do they call him? In Polish, it's Cesarz. Emperor. The previous emperor decided it's time for him to retire, so there's a new one, and they still count time in the first or the second year when this such emperor ruled, basically. So that's why we have a new era in Japan. Also, it was another minor version released 3 months after. It's like they stick to the cycle. Java 13 was released a few days ago. And it had these JEPs implemented or released. We'll get to them. And we even had a minor release a few days ago. So see, there were 2 releases of Java 13, and you're still running 8. Don't worry, I run 8 in one of our environments as well, so it happens. There's this new stuff like macOS shocked, or Apple shocked everyone with this Catalina, and now I see these tweets of people complaining that such stuff doesn't work. So it also applies to Java. Plus, there are better argument restrictions to runtime in Windows, as far as I can tell. So these minor releases, as you can see, these are not only bug fixes or patches or removing certificates. They also ship some things sometimes. They don't introduce new features, but they update stuff accordingly, basically. This is the RTMF slide. So you should read the freaking manual. There's a list of changes in Java 12 and Java 13. I believe I'm offline, so I'll go online for the next slide. Sorry, guys. Okay, but there's a list. I really recommend it to you to open it. There's the new stuff listed. There's the change stuff listed, like change behavior. There's also deprecated and removed stuff listed for Java 12 and for Java 13. Also some migration guides. So it's really worth reading, because the more you read, the less you have to write. Remember. Okay, so let's discuss the preview features. This presentation is a bit odd. Normally I walk, but when I start working, I'm afraid I will break this microphone or something, so better I'll keep sit if you don't mind. preview features. They are implementation of Java 12, and they enabled by such switch to in command line for compiler or for Java or for JShell, basically. And they are all or nothing. You can't enable certain preview features and keep some others disabled. It's all or nothing. Once you turn this on, you have all preview features enabled, basically. Once you enable them, the preview features, the version of everything needs to match, basically. Provided a certain piece of code is using a preview feature, this means that this has to be a preview feature for a certain version of JVM and the compiler, so they have to match. And we have to use enable preview in all these stuff. So for Java, Java C, which is a compiler, also in JShell, also in our build tools like Gradle, Maven, and also in our IDEs. For Java C, you don't just use enable preview. You also need to specify which release this is. Like, you need to be explicit because there are different sets of preview features for different versions of Java. That's why just enabling preview is not enough. You need to specifically say which release that is. So in this case, it's going to be release 12 or 13. And release actually sets the source version and the target version. It's kind of shortcut. That's why you could use these two or just use the release and set like 12, for example. And if you enable preview, this release or source flag is mandatory. It cannot be skipped, basically. It also emits a warning, which cannot be disabled during compile time, saying that this compilation process is going to use preview features. It's also written down to the class file that this class file uses some preview features in the version of the class, basically. So this is how it looks like. We have a lot of code to show, so maybe I'll skip, because also we have a lot of slides. I'll skip showing that to you unless you really want to. Then we can do it live. But you see, when I want to run a Java program and I say enable preview and I set source as 12, then this is this warning from the compiler that this lessons checker uses preview features. And this is basically the output of this program. The standard output, just as if it was run. If I forget to set this enable features and still I'm using enable features, like this preview features in the code, then there is the error, like C switch expressions are a preview feature and are disabled by default. So we need to enable them in order to be able to compile or run this piece of code, compile in this very case. And if I just use enable preview, as I told you, it's not enough. You must also use source or release to say explicitly which version of Java you're targeting. And once we compile it with enable preview and source being set, then this warning which cannot be disabled. Of course, you can use this switch to see exactly like more input, what's being compiled, why is the preview feature, and so on and so on. And provided I have this lessons checker already compiled, like here in this previous step, it's compiled, and somewhere deep there I have this lessons checker.class file. Then if I decide to run it and I don't explicitly set this preview features or enable preview again, then it simply warns me that preview features are not enabled. And try running with enable preview, as you can see. And also this is this version tag, because for Java, like if you compile code for a certain version of Java, the version of class file is going to be 44 plus the version of Java. So for Java 12, it's 44 plus 12, that's why it's 56. And if this class file has preview features inside, then there's also .n65535 set. It's just a fixed number, basically. But when you see something like this, a version of class file, it means that this is a class file which was compiled from Java 12 and it uses preview features, basically. So for Java 13, this is 57.65 and so on. And this is the way to run it. So as you can see, there's no warning when we run it after it's being compiled, and we don't need to set the version. We just set enable preview and it's working. One more thing, as you can see, I have set this, I have Java C version and Java version set as 12 in this very process for this lesson checker, and it's working quite okay. However, when I switch to Java 13, and as you can see, I have now Java switched to Java 13, and I want to run the very same lessons checker with enabled preview, it's not going to work, because this version of Java, Java 13, with enable preview features, will only run 57 or 57.65 and so on, whereas this class file is a version 56. That's why I told you that the compiler and the feature and the runtime need to match. They need to have exactly the same version. That's why even if you didn't change anything and the feature didn't change and it's still in preview, you need to recompile this code, basically. So it might be source compatible, but it's not binary compatible when you use preview features. Okay, how do we, questions to this, obvious? Okay, that's sorry?
One question. If I compile with the preview features and I ship the jar to some team and they don't want to write their source code with the preview features, but rather run my jar, is it enough for them to enable the JVM enable preview features switch?
Yeah, provided their JDK is exactly the same version you used to compile class files.
So it's not always much compiler with the JVM, but if you want to run the features rather than use them in your own source code, you just enable in the JVM.
If you compile your classes and they're just packed into this jar file, and then they have this version set, they 56.0 or 56 dot something.
Exactly the same Java
Then it has to be, if they try to run it with Java 13, it's not going to work, even if they set enable preview.
Okay, but with the same Java version,
it will work.
It will work without enabling the compiler.
Yeah, they don't need to compile it.
Okay.
Compilation is not needed. Once you have .class files, they can be also packed in a jar. It doesn't really matter. By the way, if it happens that you're compiling files which aren't using these preview features, and you used this enable preview for a compilation like this, the version of this class file is still going to be .0. So the compiler is intelligent. So only if you use the preview features in a certain file, it's going to set .65 and so on. So it's only certain files will be, let's say, affected by this marking that they are using preview features.
What if in this jar only one class is using preview features and others doesn't?
I think it won't load.
But
just like here. This is class path, and it doesn't really matter if it's from jar or not.
but it will do while loading the classes, not in the runtime.
It depends when you load the classes. You can have a class loader which loads classes in runtime, not when the whole thing is started or booted, but sometime after. So I think I didn't check it, but I'm pretty sure it's about when the classes are loaded. Yeah. So to set that in Gradle, by the way, to use Java 13, you need to have Gradle 6, which is still in a release candidate. There's no official version like GA version of Gradle 6, which supports Java 13. Java 12 is working with recent versions like 5, 6, 3 or something. It's also working in Maven, and you need to, for Java 13, I believe you need to have IntelliJ 2019.2 something maybe. Anyway, in the recent versions it works, except you need to have like release candidate for Gradle, and this is how you enable it in Gradle. So for every process you need to set this enable preview, like for compiler arguments, for runtime arguments here, and also for tests arguments. So provided, of course, if you're going to use these preview features, because if you decide not to use them, then it's like you don't need to set it, okay? Like if you're okay without, let's say, switch expressions or text blocks, you don't have to enable this. In Maven, it's also required to set like this enable preview, and for various plugins, you also need to add an argument line, kind of as if it was a CLI to enable preview. Yeah. And in IDE, you need to go to your project settings, and then not only set the version of the language, but you need to explicitly set and confirm that shortly after that you're going to use these preview versions. Basically, by the way, I think it's a little bit crappy, and as far as I know, it's a kind of bug, because even when you set this preview version for your project, various modules may still stick to like this non-preview version provided when they are like imported from Gradle or Maven. So then you need to like switch them again. So that's why it's a little bit tough. Yeah, that's. I mean, everybody knows about this bug. Everybody complains about this bug, and it's not a bug.
It's not bug. It works the same in every language that I tested with IntelliJ. Even if Elixir Erlang, your project configuration is default, but if you import the module and they have another configuration, Maven, Rebar,
external one, just external one, yeah,
it's more important.
So it's crappy, but crappy everywhere.
Yes,
kind of. I mean, I know, as far as I know, there are some, but I might be wrong. I was just told that there are some like feature requests or bug reports, or basically saying issues, which say that if there's something like this, then IntelliJ should automatically fall back to preview version, right? They don't, because there is no like setting enable preview or something. There's just compiler args, or as you could see here for Gradle as well. So we don't have a common switch.
Yeah, but in IntelliJ they will take care about that, but in another place in your run Maven project.
Yeah,
it's another place to park.
Yeah, the trouble is if you don't have this set for a module, then it highlights the features as not being supported because it's not preview and so on. So it will work during runtime, of course, but not when you're editing the code. Okay, so a sip of tea, if you don't mind. So you can see I can prepare it. So switch expressions, which are a preview feature, they are introduced in Java 12 and they got upgraded or updated in Java 13 slightly. And who knows the difference between statement and expression? Okay, so what's the difference between statement and expression?
Expressions are value. Statement sounds good.
I mean, basically that's it. You want jellies. A perfect catch. Yeah. More or less that's it. I mean, not digging into formal definitions, expressions have values, whereas statements are more or less like flow control. So here you can see that this is a if it's a statement in Java. So if something happens to be true, then we can do something, and this is basically a side effect because we set this value here or we set this value here to another value, and that's why we have this ternary operator as well, which is acts as de facto as an expression because it yields a value in our code. By the way, I couldn't resist in Scala ifs are expressions as well, pretty much like everything else. So it's nice that finally expressions are kind of getting back to Java from Scala. Back to Java. These are the switch statements we know from like all the time, basically, from all C derived or C++ derived languages, right? So we have cases, we can have breaks, because if we don't have breaks, then there's the fall through, and so on. So it in a way, it's a kind of go-to instruction, only sophisticated, right? And we don't see these go-tos. So we set this value, the value is declared here, we can overwrite it in here, and then we set, return the lessons. And switch expressions with break in Java 12 work this way. So still we are switching over the day, but we assign the value instantly to these lessons. And in case of Monday or Friday, we break with 6. For Tuesday, we break with 7, 8, and then we break with 0. So this is how they might look like in Java 12. Yep. Of course, there's no need to have this intermediate value. You can like return it directly. So yeah, you just save yourself a few key hits. And we can also have defaults. Like once we go through all the, let's say, school days or work days, we can have a default which is 0. So defaults work as well with this quite nasty break, I'd say. And this is the change they introduced in Java 13. That's why switch expressions are still preview feature in Java 13, because they've listened the feedback, and just like in Scala, Scala has this for comprehension with yields, and then you don't break this branch, but you yield 6 from this branch, which makes much more sense. By the way, I've heard a very nice translation of yield to Polish. It's not like super duper correct, but it's like zawynikować. And I think I really like it, because it says like poniedziałek, piątek, zawynikuj 6. Makes sense. Much more sense than break with 6 or just like stop or whatever, So I think yield is better than break. However, it's still a bit nasty, I'd say. That's why.
Wykrzycz.
Excuse me.
Wykrzycz. Krzycz. Yellman. Krzyczący. Ogłaszający.
Okay. You can also have switch expressions with this right arrow, this lambda style, and then you can see for case Monday, Tuesday, just give me 6, right? And these work just pretty much like lambdas, and this is the same syntax for 12 and 13. Nothing changed here. As far as I can tell, this syntax will also work for pattern matching in the future. That's why I'd say this is the recommended syntax, basically. So if you're eager to try with switch expressions, I would first recommend you this style with this right arrow. Switch expressions must be exhaustive. Unlike switch statements, because if you didn't cover a certain value in switch statement, you just had an error during the runtime. This doesn't work for switch expressions. I mean, you can check that in code. I should have a code somewhere, like lesson check. Let me see. This is the code, I believe. No, it's return. Okay, I must have deleted it. Okay, let's compile it. Let's copy it. Let's pretend my slides are Stack Overflow. Why not? And see, it generates an error. because switch expressions must cover all possible input values. And of course, it would be quite challenging to like list all possible integer values. That's why here we need to have like a default saying, I don't know, -1. I don't know if it makes sense in this case. It's just an illustration. It's just an example. And of course, for enums, these are much easier to list. Question.
What happens if you pass null into the enum?
Here, I count its primitive type.
But in the enum, in the 90...
Yeah, I don't have a nasty habit of passing nulls. I didn't check that. We can do such check. Why not? Let's do that check then.
Small kitty die.
Yeah, exactly. A small kitten will die, but hell, it's him who asked that. So let's find the main method. Where's the bloody main method? Here it is. So let's say how many lessons are, and let's pass the null, because why not? And let's run it and see null pointer exception.
Oh yeah.
No, Sherlock, right? Who would expect null pointer expression in such case? Okay, senior developer and consultant, of course. So as you can see, switch expressions must be exhaustive. Okay. So as I told you, this right arrow is more of a lambda style, and we don't have fall through. If we go back and take a look here, it doesn't in here, like in this case, it doesn't yield 0 for every day, despite I don't have breaks in here in this code. Maybe I zoom it in. So because when it hits, let's say Friday, then it yields 6, although I don't have break here. That's why this style is also less verbose. It's more concise, less ceremony, I would say. It also makes perfect sense because it's more kind of a functional style. So we shouldn't have like, I don't know, fall through or side effects or something. So just based on this, you should like deliver another value. Of course, we can have side effects. Unfortunately, this is Java, but I mean, this is the kind of recommendation I could give you. Blocks are still possible, so these are the way to have these bloody side effects. See, for Saturday and Sunday, we could get like really shocked why even somebody is asking how many lessons do we have on Sunday. So see, if we just like for lambdas, right? So if I have more than one statement, I need to wrap them in curly braces. And then to yield this value, I need to like explicitly yield it. So blocks are still possible in case you need them. But once you have switch expression, return is not allowed. Like if you assign the result of this switch and this is the output, you can't have return in here because this would be not obvious what actually are you trying to quit, just this switch or the whole method. That's why it doesn't work. That's why it just generates compilation error. Let's see, I should have this code somewhere in here. Yeah. See, it says return outside of enclosing switch expression. So we cannot return from switch expressions as we did from switch statements.
But what if it would be the older style with
let's say the old style didn't change. It's not touched. It still works exactly as it did. Even more, this might be a bit surprising. We can have switch statements with right arrows. And then we can return stuff from various branches, which don't have this fall through. The thing is, it's switch statement, not an expression, because we don't assign a value. So that's the way to tell the difference. If you have, if you kind of assign the result of the switch, then it's expected to be switch expression, because expressions need values, right? Or better said, to provide a value, you have an expression. Whereas when you don't return don't assign it, means there's no value, means this is just switch statement. So we can use this new right arrow style, this lambda style, even with blocks, and you can return stuff. And this just quits the whole method, provided I had some more statements here, it would work.
Will yield work here as well?
No, because we can't mix the styles. It's either statement or expression. It can't be like some branches are statement and some are expressions. Like the whole switch needs to be expression or statement. So this thing is switch statement. Once I try to assign something, let's say var stuff, then you see it doesn't work. Because by this assignment, I switched this switch from being switch statement to switch expression. Okay. Switch expressions don't define their type. Like in a method really defines its type, right? You have void for this method, or methods need to have some types, as they say, nabestypiu I void typa. For this switch, as you can see, I don't need to assign set the type of this stuff being returned. Meaning, if I'm switching over an input, which is an integer, here I'm yielding, that's a good description, a string, and here I'm yielding integer. So I think we can run it. Let's run it, because why not? We are here to break stuff after all. J shell enable preview. 2 dashes are needed. Yeah. So let's paste this method, and let's run it. Right. And as you can see, I'm very small is a string, and 7 is an integer. So this thing, as far as I know, is inferred to be serializable. So we could set it to be serializable because it's like the, let's say, the lowest common ancestor in this whole inheritance tree. Or also there are some aspects that this could be like a cross type, or maybe there's another description for this. So var allows more options than ordinary, just ordinarily setting the type.
Well, that's going to be a problem in code.
This is demo, right? Don't do that in production.
Okay, but that makes a Java dynamic language, yeah?
No, it's not dynamic. It's still static. This type is inferred during compilation time, not runtime. So it's not dynamic. Dynamic means the type is defined at runtime, and if it's defined during the compilation time, then it's static. And it's static. It should be. We can check that.
Okay. Let's try to define what is the type of the. You change the void to the something.
I think should be serializable, say, because both string and integer are serializable. And if I set it just let's say a character sequence, then it won't work, because then the input, which is integer, cannot be converted to character sequence.
So they're looking for the first common ancestor.
This is how var works. Yeah. This has nothing to do with switch expressions. This is just how var works.
Well, you can use the object, right?
No, I couldn't. I couldn't use objects, sorry.
It's not JavaScript.
I'm not that highly paid consultant.
By the way, can you pass var into a switch expression?
Here, if you could set it as var as well, why not? Var doesn't mean it's dynamic. Yeah. Var means, hey, Mr. Compiler, be so kind and infer this type for me. This is what it does. It's not like var from JavaScript, okay? It's more of a var from Scala, if you know Scala. So it can be var, like we have also other maybe I don't have any other instances here. because var works only for local instances initialized immediately. Or I could use like var here as well. Oh yeah, see, I can use var, but I can't use it like here for a parameter, obviously.
Class member also, right?
Yeah, so it doesn't work. The only place it works right now are local variables, which are initialized instantly. I'm also not able to do something like this. I can't. Let's double this and
lambda parameters.
Yeah, since 11 we can also use that in lambda parameters. But see, I can't do something like this because this input variable doesn't have these. Is not basically initialized instantly. It has to be initialized instantly. So this doesn't work as well. Okay, back to slides. Yeah. So why do we have these switch expressions? Because there are plans to evolve into pattern matching. Maybe I can switch to that. I'll just show you a brilliant article of Brian Getz, because this is still not Java code. It's like what Java code may look like in the future, and that's why switch expressions are getting introduced. So we all know this bloody construct. So the idea is to have something. Yeah. So we could have something like object is instance of integer. So we don't have something like this. So we could have instance of integer, and here's the an alias when it's the integer. So here we can use the I, and we know it's the integer basically. And this could be very useful for like equals, because then you could like instance of it to point other. I know that Kamil is very happy right now, because equals could be a little bit simpler, but this doesn't satisfy you, right? I mean, because it's not exactly the same class. Yeah, but this will work in Hibernate. Sorry, mate. So that's why they want to have this. And in the future, we might have like a case integer I. You see, this looks more and more like Scala. So we could like format it like numbers, or then like floating numbers. And even when we have these polymorphic types, and we then seal this, we have. Let me skip a little bit here. So we can have the construction patterns like the constructors or the unapply method in Scala. We could have something like this, so we could match also on internals of the classes. And to get these deconstruction types, maybe in the future we'll have so-called it was in the other link. Record types, which might look like this, pretty much like date classes or Kate classes. So we would say that it's a record point, and that we would get constructors, deconstructors equals hash code, all the setters and getters generated for us. So with pattern matching, if we seal this type, this might look like this. So we don't have to this unapply or deconstruct method. So that's the long term goal, or maybe not that long term. Some say we might see that even in Java 14, some elements of it. In general, I really recommend to you to take a look at this pattern matching in records, and in general on the project Amber and Valhalla. Another preview feature, text blocks. They were introduced in Java 13. This is this jab. And do you know this poem? Yeah, I hope you do. Anyway, we know this style of declaring strings, right? Like this \n to indicate it's a new line, and so on. This doesn't look that bad. It looks worse when you'd like to have like JSON or XML and keep the indentation, and you need to escape the quotation marks and so on. Then it starts to look not so nice, but let me put it that way. So this is how strings are working up to 11, and of course this style still keeps working in Java 12, 13, and as far as I can tell, it will keep working forever. So if you really want to stay with this style, I mean, you can declare your strings like this, no problems. However, once you enable these preview features in Java 13, it may look like this or this, which I believe is a bit nicer to read, basically. And these are called text blocks in Java 13. Yeah. So what defines text blocks? So you need to open it with 3 quotation marks, and they need to be followed by a new line. See in here, there's a new line. I can't continue writing here. And they also need to be closed by 3 quotation marks somewhere. And position of this closing quotation marks matters. I mean, I know these strings from Scala, and I'm not sure I like this style they picked for text blocks in Java, but we have what we have. And once they're created, they can be used just as any other string. I mean, they are just strings, and whether you define a string in text block or as a string literal, it doesn't really matter. I mean, it's a string. Yeah, I can even show you that again in J shell, but this time in 13. So J shell enable preview, and let's say var literal. Yeah, because why not? And var block 1. And let's see if they equal. So literal equals block. It does. It might go even further. They also, I assigned it. Sorry, I spoiled this. I should put, let me redefine the literal. Yep, and I should have set to equals. So you see they're even equal when it comes to referential equality. See, they're exactly the same string under the hood. Yeah, so closing and escaping. This doesn't compile, this first line, because we don't have a new line here. And the second line doesn't compile because we have no closing. Like when you open a text block, you can close it. You have to close it as a text block. It can be closed as a string literal. And we can, if you need, due to whatever reason, to have 3 quotation marks listed, you just need to escape any of them, like the first, second, or third one. So we can do it like this. Let's see. Sorry, I have no print line method defined, so let's get rid of the method, but we should declare the string. See, and this is the string. So I have, when it gets printed, I have these 3 quotation marks, and I can, I could print it, I could do whatever.
By the way, why the second string doesn't compile? Shouldn't the
this one?
Yeah, it should be a string, right? It should be a continuation of the string.
It doesn't compile because...
Right, so yeah, because there is no ending.
Exactly. Like here was.
So formatting here is wrong because this ending brace and semicolon should be red because it's still string.
I mean, don't look at the coloring because this bloody JavaScript plugin is not aware of Java 13 syntax. Okay, so let's imagine we are all colorblind. Okay, you don't see colors right now. It should be, yeah, exactly. This is still the string. I can place it for you. We can see that in IDE. Just let me check this 13 version, like here, because why not? See, and it's still, it's still green because we need to close it here. And of course it yellows because we don't have this print line method. But if I remove it and var block, still there's something going on. Okay, I know what happened. Yeah, the thing happened. I told you. See, here I have the preview, and here I don't have the preview. So I need to set its preview, and now they work. And just as Camille said, it's still interpreted as string. That's why Camille will get jealous. If I don't destroy anything. Yeah, for having the compiler in the eye. Okay. Yeah. More examples. Indentation. This is really a tricky beast in text blocks. I'll make it bigger. So actually, I should have it in here. Okay. Yeah. See. Indentation test, and yeah. Let's run it. Okay, and let's see. So we started this method in here. I mean the output, because these are the previous ones. So also zoom in a little bit to make it easier for you. Okay, so this one is not in.
Yes.
Yeah, sorry. And this is not intended to. And this one, I need to fix this, sorry.
It was not intended.
Yeah, in fact it was, it's just, sorry, wrong spell checker. And this is not, has no indentation either, as you can see. They all result in this way.
This was,
however, you might be, okay, jokes aside, you might be wondering, but I have this indentation here. So why isn't it printed as without any indentation?
Because ending matters.
Exactly, because the bloody ending matters. So see when the ending is here or when the ending is here, or even then it's not intended, basically.
Ale prawdziwego mężczyznę się poznaje po tym, jak kończy, tak?
Politics aside, please.
To nie jest polityka.
If you start the text before indentation of the closing mark, yeah, so
I'm not sure if I have this example. Like this is intended, like this thing, or I could, like when I do something like this.
yeah, exactly.
Let's run it. It's not intended either. See. Because I'll explain it to you, because there's actually quite a simple rule, but that's why you can't rely on like automatic formatting for this, and that's why I think they made this thing. Like in Scala, there's this strip margin, and it does everything, and it seems to be more complicated in Java 13 at the first glance, but actually it's not that difficult. So we have indentation here by a single tab, because this closing is like one white character to the left. So see, I can move the whole thing to the left as well, and it still will be intended. Sorry. And this is very intended because I have two tabs in here. So that's why I have two tabs in here, but it's like the indentation is relative to this closing line. But I don't have to put this closing line, this closing on a separate line. And then you don't have to close the text blocks in the text in the next line. You can just close them instantly. Or we can have empty lines or more empty lines, as you can see, and they will get printed. And still we can have, because text blocks are strings, after being initialized, so we can concatenate them. Here we can see the concatenation, and we can still escape characters. Like you can see the tabs here, which is like we have this due, and it's like separated by tabs. And even for text blocks, you see I can still use it as in this format. So I can put that the person C, person D, and then I can like assign certain variables which get injected because. Okay, we'll get to that later. So if it looks confusing to you, it's actually not that difficult because indentation. It works this way. So the expected output is that at least one line from this text block won't have any indentation. Like string text block is created so that they expect at least one line to start without any white characters, not spaces, but white characters in any Unicode encoding, as far as I can tell. So the closing is in its own line. It counts as a line 2. So and all lines with empty spaces aren't taken into account. So here, like, see, I could put tabs here and a space, and they're not counted as well. Basically, see, there are no, like, see, I try to select something and I can't because they get stripped. And all trailing spaces get removed. So if we put like spaces here after the end, and I run it, and I have this, and here I see there are no spaces. See, I can't select anything. It's just a new line character. And all white space characters are counted equally. It's because they didn't know how, like, because we can mix, for example, spaces and tabs, and they didn't know if your tab is 2 spaces, 4 spaces, 3 spaces, 8 spaces, or whatever. That's why they said each character counts as one character. That's why if we have like spaces here and tabs there, this OR will be heavily indented, you see? Because it's stripped here 1, 2, 3 white characters, and we have 1, 2, 3 spaces and much more, much more than 3 spaces, basically. So it cut the first 3, and the rest remained. That's why we see the rest in here. Any questions? Because this might be confusing at the beginning, but yeah, this is the whole algorithm, basically. Take all the lines, count white characters, take all the lines, skip the empty lines, filled only with white characters. Then for all the remaining lines, shift them to the left as long as at least one doesn't have any white characters in the beginning. And that's it. That's the whole algorithm. You need to play with that, right? Okay. The empty lines I have shown you because when we selected, we've been there. So they are just simple strings. We don't need explicit white spaces when we define them. Escaping works the same way. I have shown you with tabs, and we can concatenate them. Yeah, so this is it. Basically, so we can use it for string formatting or with these tabs. And sadly, text blocks aren't raw strings, literals. There was a JEP which didn't make it into Java 12. It was in one of the preview versions, but then it got unmerged because it generated too much, even more confusion as far as I can tell. And raw strings were an example to do something like we have with these 3 quotation marks in Scala. They weren't exactly the same, but they were more in that style. They would be more useful for regular expressions because we wouldn't need to escape stuff, for example, in this bloody regex, which you shouldn't use blindly. So don't confuse raw strings with text blocks. However, some say that raw strings were not abandoned, but only withdrawn. So they might, they're still on the table and might enter the game later. There are also new methods in strings. so we can indent our strings with given number of spaces. Since Java 12, or we can strip this indent just the way the compiler does. We can transform our strings. So for this transform method, we could use, for example, integer.parse. Or instead of using this static method string.format, we can use this formatted, which is an instant method. It's using this enhanced deprecation, because if a method is added because of a preview feature, then it's being marked as deprecated for removal. So if they decide to, let's say, cancel text blocks in the next future release, then this method will be gone as well. And if text blocks are become a regular feature of the language, or standard API or whatever, then this enhanced deprecation will be removed from this formatted method. That's why here you can see this red line, because it's deprecated and marked for removal. But it may look more appealing than just using string.format like this formatted, because unlike Scala, we can have this $ something, or so the string is not interpolated in place. We still have to use this format or formatted methods. There's also translate escapes if you're reading strings from external sources. There's programmer's guide to text blocks from the authors of this JEP from Jim. So everything I told you can also be found here, and they have this incidental white space. Actually, this is the way it's called, this incidental white space, and here is the algorithm you see of selecting the lines which should not have any white spaces, and that's why they kind of shifted to the left. See? So this is it. And by the way, I don't know if it's recommended here. I think it's recommended somewhere in the docs that we should kind of manipulate the indentation by moving this closing to the left or to the right. And I don't quite feel it. I think we should keep it where it belongs and indent stuff here. I mean, this is the style I would choose. But you can choose whichever style you prefer. Or you can then call these methods strip indent or indent if you prefer. Compact number formatting, which was introduced in Java 12. It was a ticket for this. So the idea is that when you get a compact number instance from number format, you can format numbers. And for short displays or whatever, you'd like to abbreviate them. So for some languages, it will result as 1K. In Polish, it will result as 1 tys. Mind you, there is no tyś, but tys. Right? Maybe. Or in German, this would be like this. And this is a code. Let me run it. It's Java 12, so the other window, and we have compact number format. So here's a simple demo. I guess I need to. What did I pulled this tiled. Okay. Let me make it bigger. And let's run this code. I just have a list of various locales. By the way, I was shocked that the language code for the code for Ukrainian is UK. So you have just these numbers formatted in a short style and long style for various languages, and this is how it looks like. In the United Kingdom, when you speak English, then 1000 is 1K or 1000. And in Polish, it's, as I told you, 1 tys or 1 tysiąc. And so the story goes. There's also for Ukrainian, there's a different encoding than for Russian, because this tysiacha and here's this tysiacha, if I read it correctly, but I might be wrong. I mean, the languages are different. Just remember that. And for Belgium, I was a bit shocked that some people consider Belarusian in Belarus is considered as a minority language. So, anyway, let's not dig into politics. And in Belgium, when you speak French, Dutch, or German, you have different codes because it's 1 kilo, 1 million, and 1 milliard. So, 1 milliard. That would be. So if you have you need to switch the locale and you need to abbreviate it, then you can use this number format and get compact number instance. You can select the locale and the style, whether it's going to be short or long, or you can use this default method, which just returns you the short version. Sadly, it's still wrong. I'll show you. I know what you mean because I was that picky too. This is what you mean, I guess. Like 2. It still will say, or here we can say 2. It will still say 2 t-shirts. So it will not go with the whole declination. See, it's like. Ooh, yeah, exactly. I hope I will meet. Let's see who's behind it. Do I have the jab for this? Let's see who's responsible. Maybe we should sorry, wrong key. Maybe we should mail the guy. What the heck? I don't see any names who closed it.
Klikaj się w ten, w metodę. Tam będzie winny.
You really think so? Let's go this path. There's no author. Sadly, they stopped publishing authors. Maybe on top. Scrolling. Let's find. There are 2 suspects.
I like, but it's 1.1, so we need to analyze the
ticket and
log, so.
and the GitHub or Mercurial. I think they should use it.
There's a library for IBM, I believe.
They are as you know, internationalization and localization isn't trivial stuff. So in order to avoid such mistakes, anyway, because we have lots to cover. I have a different talk for language purists, so it's not this one. Ting collector, which was introduced in Java 12. Do you know this command from Linux or Unix? So let's check what it does, right? man-t. This is what it does, basically. So when you need to output something from a command, let's say not only to standard output, but also to a file or 2 files in standard output, like you need to spread the output to many targets, let me put it that way, you can use the t command. So that's why we have t collector in Java 12, and this is the signature. Easy peasy, isn't it?
Pirate.
Maybe it looks a bit easier this way. Or when what did I do? Sorry, this. I'm just.
Chciał się tym Ubuntu pokarmić.
No, it's not Ubuntu, it's Reveal. So it works like this. First, we get this team, like this is the method call, and we have 2 collectors. One collector, which takes the type of the items we have in our stream, and might have a different type of result. And we have another collector, which might have a different type of result. And then we have the merger, which could be a function or lambda, which should merge these 2 into a single result, because as you know, in Java, we still don't have tuples, maybe record types with issue that. So that's the thing. And when it can be useful in situations like this, I should have a code for that. Let me check. teeing collector. Yeah, see, something like this. Because let's say I have a stream, of longs, and I need to do the two things. I need to get the sum and the count. So this means I need to create two streams, because we can't re-enter the same stream in Java. Like we can have terminal operation on stream, only one terminal operation on stream in Java. And as Brian Wiemer says, the two most important things about streams in Java is that first, streams are not data structure, and second, streams are not data structure. Remember that. That's why we need to create a new stream from scratch to have like such a naive approach. Of course, we could reduce, and reducing would work this way. So we have our accumulator, which has no count and no sum. By the way, this is not the way you should define accumulators, because your stream might be empty, so you don't have 0 elements. You have you might have a count would be 0, but the sum won't be 0 of an empty stream. So this is just a demo, and then we have the how is it called? I always forget that. How is it called? Then it's the let's get into here. It has nice names. Yeah, the accumulator and the combiner. So this accumulates the values. So when we have this previous accumulator and a new element, we accumulate it. So we update the accumulator. So we just increase the count and we increase the sum, obviously. And then when we have two accumulators, because we could run that in parallel, this could be a parallel stream, then we need to combine two accumulators, right? This works, this is like proper math and so on. Kojo is happy because this looks pretty much functional, but it's not easy to read, right? So then we could use this teeing, which is like this. I have again this gimme stream, and I collect this and I create a new teeing collector, which is kind of a composition of two already existing collectors. One collector just counts and another is summing longs. And then at the very end, I just have this merger function, which is just the constructor of this count and sum, which is kind of a trivial class acting as kind of a named tuple or this record type, which we still don't have. So yeah, this is basically what happens. And when I run this code, let me run this code. And let's hope it works. Yeah, see? So I had this sum and count, then I had this reduced version, and I have this collected by teeing. And so the sum is this, count is this, and I get exactly the same results either by reducing or teeing. So the rule of thumb is if you have already a collector which does the thing for you, like this thing and this thing, maybe teeing would be easier than reducing, just to read stuff. By the way, don't reinvent the wheel. There's a nice method called nice collector summarizing long, and it does this thing for you. This. See? It does everything. Counting, summary, minimum, maximum, and average. So we don't have to reinvent the wheel unless it's too slow for you. And we can do also other teeing like this here. See, we have this stream again. And by the way, now I don't have this tuplish type. I just use an array, which again is demo only. But I can tee collectors, and I have filtering collector, which counts only even numbers, and the other one counts only the ones which are divisible by 3. And see, there are that many numbers divisible by 2 and that many numbers divisible by 3. And that's actually true. This is the output. So see with this, because I have this filtering from standard library, this filtering collector, it's much easier to use it in teeing collector. If I want to find out in a single pass over the stream how many numbers divisible by 2 and 3 I have. So I don't have to, instantiate 2 streams, right? I can do it during a single pass. That's the benefit of teeing collector. Questions? None. Okay, so where are we? We are reached like more than a half, so I suggest we take a short break. Okay, so take your seats, and as I have told you, because we are about to conclude team collectors from Java 12, if you have some other collectors you could like combine or something, and also remember that you can tee them deeper, so there's not just two, you can have more. If you have three, you can just use double teeing, for example. Then teeing collector might be really useful to increase the readability of your code. Okay, there's a new method in files. I don't remember whether it's class or interface. We need to check. It's called mismatch, and it's introduced in Java 12. And this is the signature. So we have two paths, and we just want to see if there is a difference in this in these files or not, or these paths, better said. So it's 12. We're in 12. Okay. Let me see mismatching files. Yeah. So this is quite simple. I'm creating one path here and the other path here of text files, which are here, and we want to see if they have any difference. Because how mismatching files works is that it will return us -1 if the files are identical. I mean, if all the bytes are exactly the same, and if there's a difference, it will give us the first instance of the difference. I mean, counting by bytes, basically. So if we run this code, we see the files differ at byte 21. So we can compare these files, and yeah, they actually differ. How could that be?
UTF!
Yeah, UTF. This is Latin, and this A is Cyrillic. So they look pretty much the same in this font, but actually they are different bytes. So this is the difference that was spotted by files mismatch. Let's see. I'm just curious. I forgot. Yeah, it's a class. It's a class. So if you need to check if files are the same or not, you can just now use files mismatch. Completable future with better error handling. That's also a thing we got in Java 12. Sorry, maybe I'll move the microphone like this. Okay. So of course we know completable futures from previous releases, like Java, which Java version that was 6 with the fork join pool and stuff, right? So I think it's quite old, but they've been adding more methods to completable future, and now we have an exception handling methods to completion stage, because completable future implements or extends completion stage, and these are the new methods. Because so far we had only exceptionally. So if we had an exception at the given stage of processing a completable future, we could only handle it in a synchronous way. Now we have these 4 async methods. So when this exception happens, we can, or this function, or of course lambda will be executed, or this is an overloaded version, so we can select an executor, which is very handy. Let's say you want to have your error handling or exception handling on different execution pool, which, for example, just has one thread, or which threads are, let's say, with lower privilege, or whatever, because you might want to execute it somewhere else in different executor service. There's exceptionally compose, also a new method. So when this exception happens, this throwable, then we can combine it, or let's say, okay, then I want to try this other completion stage, or what's it called? Completable future. Sorry. And then there are these two, so we can do that asynchronously. And again, we can also select a different or distinct executor service instead of, let's say, the default fork join pool. Okay, I need to fix this slide. Sorry. Let me show you that in code. So we have this completion stage demo. And okay, let's zoom it. And we have this demo exceptionally, because exceptionally is what we know. We had it so far. So this is this demo. So we supply us an asynchronous task to completable future. And of course it's going to blow because we cannot divide by 0, although some folks still push such feature requests. Really? And then exceptionally we can handle this exception, and we can, let's say, return 0, and then we can accept the result of this. So let's call this code, and the result is, ladies and gentlemen, yeah, of course it's going to blow. We are handling this arithmetic exception division by 0, and we're accepting 0. And one thing you should notice is the same thread from this fork join pool. It's the same thread. You can see this thread ID and of course the name. However, if we do that in a synchronous way, which is, let's see, sorry, this should be exceptionally async. Yeah, this live coding demos, sorry. Let's run it again. And see, then when things blown, then the handling of this error has been set to another thread. That's why it's called asynchronously. It's because the threads might work in parallel now. Okay, so we have this new exceptionally compose, which works like this. So if things are going to blow, and they're going to blow, by the way, I'm just impressed how smart this IDE is getting. I see it can compile and see that this thing is still out of the bounds. And basically we have a plan A and plan B, and we can exceptionally compose this plan. So we run plan A, and when we compose it exceptionally with plan B. So when something goes wrong with plan A, we can continue processing with plan B. This is the idea behind exceptionally compose. And then we have this final plan, and we apply and accept the result. So let's run it and see. We have this, doing something sane, which is plan B, and we have plan A, which is going to blow. And then when it has blown, we are processing with this plan B, because plan B returns -1, so when we double it we get -2. So obviously this is like doing something sane was combined here. And when we do that in a synchronous way, then you can see after things have blown, we are again having a different thread. I would need to try with different fork join pools, because it jumps back to the same, but you can in this option, using this overload method, you could say in here, yes, where are we here? We could say use this other execution service, single threaded or whatever. By the way, this debugs show you why when you, just like Tomek Nurkiewicz said during our 10th anniversary, when you're creating thread pools or execution service, you should name them, because this is just this doesn't tell you much. It doesn't tell you anything. In fact, that's why it's a good habit to name your threads. And that's why it's wise to have your own thread factories and execution pools using them. Anyway, so these are the methods we can use to handle our errors or exceptions, better said, asynchronously in completable futures.
Naming a trees, it's like naming a children. It's hard to survive any of your children.
Yeah, I mean, maybe it's a kind of the same principle that when you have way too many children, way too many threads, some problems happen.
Yeah, if you have a problem with the naming, that's a problem. Yes.
Yeah, it's one of these two. We'll get to the second one. Sorry, this slide should go. Before. What also got redone is that this socket API got re-implemented because socket API we had up to Java 12 was actually legacy code. It was a mixture of C or native code dating back from JDK 1.0. So now, thanks to NIO, it got re-implemented. So it's, although this in theory it's portable across all the operating systems, it's a result of this JEP. And basically we have a new implementation, NIO socket imp, which is a drop-in replacement for plain socket implementation. This one was developed to be easier to maintain, to debug, and they even tried to mimic or to replicate the undocumented behavior. However, there are some differences between these two, and if you're relying on these undocumented side effects or whatever of plain socket implementation, there's still a way for you to opt out or to switch back to the old. You just need to old implementation. You need to set this system property. Use plain socket impl. So once you set it in your system properties, then the old implementation is going to be used instead of the new one. Every time, for example, when you create a client socket or open a server socket. There are some changes in garbage collectors, of course. As far as I know, from the public ones, 3 were affected in Java 12 and 13. G1, Shenandoah, and ZGC. So G1 was changed in 12. So now this JEPs says about abortable mixed collections. So roughly speaking, I'm not going too deeply into the details also because I'm not a garbage collector guy. Like G1 divides the memory, roughly speaking, into kind of regions, and the size of those regions or these areas is based on some heuristics. So like every cached stuff, sometimes these heuristics get stale, get outdated, and then this garbage collector takes too much time to free the memory or get rid of the unneeded objects, basically speaking. So previously, it was causing extremely long garbage collection pauses, and now such two big regions can be just aborted in the middle. So that's the change. And also what G1 can do since Java 12 is it can return unused committed memory. So let's say you had a peak, you were using a lot of memory, of course still in scope of your XMX max heap size, but then there's not that much load, so the memory can go back to the operating system if you're using G1. And this is the result because this Jotman, Bruno, and other people ran an experiment, and it turned out that during the night, when using G1 since Java 12, when the Tomcat was idle, they were able to get back 85% of the heap, which means when you run it in the cloud and you pay for the RAM, you can save the money. Because you don't need to occupy the RAM which you don't need. Because, let's say it's like middle of the night for your time zone, but it's like middle of the day for another zone. So other people can use it, and then they pay for that, and you don't pay for that because you don't need to ridiculously keep this memory allocated to your JVM. So see, that's one of the reasons why maybe you'd like to jump to Java 12 directly or Java 13 because of this G1. I mean, you can save real money from these improvements. There's a new garbage collector from Red Hat. It's experimental. It's called Shenandoah. It's also there's a JEP. I mean, I'm posting the links to this JEP so you guys can like read details later if you're interested. These JEPs are actually they are not very techy. I mean, they're quite nice to read. Like we can dive into one of them. Why not? And they are like showing summary what's not the goals, when the success will be achieved, what's the description, and of course the reason why Red Hat started to developing this Shenandoah garbage collector is they wanted to have shorter and more predictable pauses for GC, even for huge heaps. So to use it, you need to. I'm not sure if it works on Windows. I mean, we'd need to check that. It doesn't. You say it doesn't.
So not for Minecraft.
Maybe not for Minecraft. I think in Minecraft the garbage collection might not be the critical stuff. This is the way you can use it. First, it's an experimental feature, so you have to unlock it, and then you can say that use Shenandoah GC. Basically. There's a very nice wiki page when they're describing it with more details. Okay, it's still loading. It's very slow, unlike the garbage collector. And there's a very nice talk by Alexei Shipliev from Red Hat, who's also involved in developing this garbage collector from DevOps Belgium. He explains how this works and so on. So in general is to make more and more garbage collection work parallel with to the execution of our programs, so we don't observe so long GC pauses, basically. And it got improved in Java 13. They're supporting all 32 platforms. Now they are respecting minimum heap size when uncommitting unused memory. So I mean, they are not going below the specified minimum heap size. They had some refactoring, let me put it that way. So it makes easier to improve it even more in the future. I mean, you see the whole list of features if you're really eager to get through them. There's also another new garbage collector called ZGC or ZGC. It's also experimental, and it comes from Oracle Corporation. It was introduced in Java 11, and it received some improvement, maybe even earlier. But I was using it with Java 11, and it got improved in Java 12 and 13. Also, there's a wiki page for ZGC. Let's see this. Yeah, it's like they explain how it works. For Shenandoah. And for ZGC, there's also a wiki page. And this is in 12, they made this finally work. I mean, unloading classes. If you're not using certain classes anymore, they can get unloaded from the memory. And in 13, they also introduced a new parameter called soft map heap size. So if you set it, of course, this should be below your maximum heap size. If you set it, the ZGC will try to keep to this limit. But, if it can't, instead of throwing out of memory error, then it will go up to the actual or the real heap size limitation. Also, they extended the heap size. They can handle up to 16 terabytes, which I think is quite huge. And the goal, as far as I can tell for now, is to have GC pauses no longer than 10 milliseconds. And when they do some benchmarking or for average applications, they usually have something like 2 or 3 milliseconds, something like this. I'm just calling that from my memory. So I can be sure. Anyway, it might be worth trying, provided you're okay with experimental garbage collector, and they're not doing that for Windows. So yeah.
If you unload the class, there are some things that have to be saved. Yeah? For example, if you load the classes, the static code of the class is invoked only once. Yeah? So if you unload the class, and then after some while you try to load it once more, so it has to remember that this static block was called.
Actually, I don't feel I know enough. I don't think I know enough to answer this question.
But it doesn't work like that. If you load the class, they go to the different place in the memory. Okay? And that's why the Docker doesn't work well with Java.
Old versions.
New versions works better. But in this case, that means you return to the operating system the memory. Yes, so you say, I don't need that. It's
but it's
an allocation in C.
Yeah, okay, but I think that sorry, Mariusz? Mateusz, sorry. I think Mateusz was more referring to like side effects, for example, like increasing counters or something like this. I can answer this, but I think it's more general problem. Like I'd say it should also happen like with loading or reloading modules in OSGI and stuff. So I can't answer this question. Yeah, so how to use it for ZGC? Again, we unlock experimental features. We say to use ZGC. It's a good habit to set maximum heap size. We can also set, but it's like from 11, the maximum number of threads because ZGC is meant to be parallel. That's the trick. So they don't make like everybody freeze because we're garbage collecting. They try to do as much work as possible in parallel and just, to make this GC pauses, this halt, only for like very needed stuff. That's the philosophy in Shenandoah and ZGC as far as I can tell. There's also a video by Erik Österlund, also from Devox, I believe, or Java Zone. Anyway, there's a new thing, Constants API. It was introduced in Java 12. This is the implementation of this JEP, and it has something to do with creating these constant pools for classes. And that's all I know, sorry. Now there's application class data sharing. Question, who's using application class data sharing? Just one guy, and he's not a Java guy. What a pity. Anyway. They were introduced in Java 10. They received constant improvements like in Java 12 and Java 13. What's application class data sharing? Or actually, what's better said, what's class data sharing archive? To put things quite simple, maybe even in oversimplified way, is just when class loader loads your classes from the class path, basically, it has to read the files, the bytes, whether they come from your disk or storage or from loaded, from URL, whatever, depends on the class loader. The class loader needs to kind of do, it needs to do the stuff that was done in the Minority Report by Tom Cruise, like to set, everything where a certain class belongs or comes from, and so on and so on and so on. So there's this whole structure, this structured memory. And when you run the very same application over and over and over again, it really does the same job over and over again. And it's actually, there is no gain. It's only producing CO2, basically. So instead of rereading that from actual classes, like jar files or whatever, we can, once we have this whole structured memory, we can dump it to a file. And then during the next startup, we can just, instead of doing that again using ClassPath, we can load that from this file, or JVM can load that from this file. So we save some precious time on startup. The more classes you have, the more time you will save, basically. Also, when you happen to run many instances of JVM at the same host, all JVM instances will map the same region in read-only mode from your RAM, basically. So also you will use less RAM. So there's a CPU benefit and memory occupation benefit when you start using application class data sharing. And the thing with Java 12 is that now Java comes with its own class data sharing archive already enabled. Previously, it had to be done by installer. Now it's When they release JDK 12 and above, you will get CDS archive within your JDK, like distribution. And they simplified also the way the so-called dynamic application class data sharing archives are created, because previously, like since till Java 12, you had to first create the list of the classes manually or dump the list of the classes. Then you had to make a static call to create this class data sharing archive, and then since third call, you could actually use it. And here we have the improvement thanks to this archive classes at exit. Because at the exit, our JVM process will simply dump this archive so it can be reused in the future. I will show you how it works, because it's really a nice thing to have and nice thing to use. Java 13. We have this script, and what does it do? First, it removes this archive, provided we have any, and then we run our application and we tell it to dump this CDS archive at the very end, where it just finishes the execution. So this file gets created. See, AppCDS gets created. Then we disable CSD data totally, and from the JDK in our application, and we run this application. Then we just run in the default mode since Java 12, so the CDS is loaded because it's present, and hopefully we observe some time improvements during startup, and then we can, in the last step, we can use the shared archive we created here in this dynamic way. So this is the whole script. We generate this CDS archive, then we run without nothing, then we run with the default, and then we run with the dynamic CDS we've just created. With the CDS archive we've created dynamically. That's proper description. Let's run it, because why not? And I should go into CRC main Java, I should go into, where should I go into? It's using Java, yeah. So into CRC main Java. Yeah, and let's call the script. Yeah, I mean, again, an asterisk, a huge warning, actually. This is not a proper benchmark. Okay, so whenever you try to show somebody something like this and say, because Piotr did it as benchmark, no, it's not a benchmark. So we've created this, we are using this real time because it's like the clock time, okay? Like the clock on the wall time. So we've created this archive, and it took us almost half a second. Then we are running without anything, and it takes like 370 milliseconds. Then when we enabled the default one for Java, so Java doesn't have to load its own classes. It just can use this archive. You see, we have a little performance gain. And when we use this dynamic archive, we have even more time saved. That's why when you spin off your processes quite often, you should really use it. Or when you spin off a lot of instances, or even more than one instance on a host of the same application with the same class path, you should use it. Because, it saves you time, it saves you memory without any effort. Actually, so one thing, because we've reached the second problem of IT. I mean, we had the naming before, and now it's the cache invalidation. This is the cache. I mean, this archive. So we need to know when to invalidate it, right? So when you change when you release a new version of your application, you should. The safest way is to invalidate it, meaning rm this file. Okay. Okay, let's go further. There's much more to cover in Java 12 and Java 13, but I think we've already reached the time. I mean, more than 2 hours, or just 2 hours, including the break. For Java 12 and 13, read the freaking manual, because there's more stuff. Like some more changes to NIO stuff which got removed or deprecated, like which certificates got removed, like root CAs, more to this Japanese new era. They also describe which Unicode's dialect they've adopted. Like, I mean, I know we have Klingonian for a few years, but now they have new dialects included in Unicode 12.1, as far as I believe, and so on and so on. So there are more and more improvements. It's really not that difficult to read. Maybe I load a sample one. See, you have like different releases, and let's say this 12, and it basically says what's new, and you have this support for Unicode and blah blah blah, and so the story goes. See this compact number formatting, Japanese New Era, concurrent class as loading, the stuff I've described to you, and some of the items are like missed from this list. So that would be it. And thanks a lot for coming and for staying so long, because it's quite long actually. And there's one thing I'd like to ask you, because I'm going to give this talk this weekend on Devox Ukraine in Kiev, and next week in Devox Belgium in Antwerp. So I would really ask you to not always and everyone provide your feedback, but also this very time, because I would like to know what you guys think about this talk, what stuff should be improved despite indentation. I can accept any feedback, even paper one. So this is a link to a simple poll. See, it's really simple. It's anonymous. So I would like to know what you think. So please spend like 2 minutes letting me know what could be improved, or what was okay, or what wasn't okay. Still some folks taking pictures. There's a link below, or the QR code if you're more fancy to do it this way. This is the link to the slides. The slides will get fixed. I mean, this indentation, because it's online, and also this flipped slide also will get fixed. So if you'd like to see updated slides like tomorrow or the day after, they will be updated. This is the link. The code will be published as well this week. It's just I didn't have enough time to like polish it or double check it, but it will be available this week on my GitHub. It's open source, so if you'd like to get updated, I will publish it on my Twitter. I hope our host will retweet that. And that's it for today. Thank you very much, and happy migration, I wish.